Hi, everybody. Thank you for coming to the session. That's already quarter after 1 p.m. So I suppose I will be waiting a couple of minutes more. I hope that you can use the chat on the right side. Would be happy if you can just drop a word whether you can see me good and perfect, and you can hear me well. Perfect. So, good. Yes. Thank you so much. So, yeah, let's start. It's a little bit, I suppose, unusual session where I've been going through the program, and this is, I would say, mostly very nice educational sessions for startups, how to do certain things. I brought today a little bit more content on the topic that personally inspires me a lot. And I think that you've seen the reports, latest reports on the media about how sustainability is getting more and more important. And you definitely know that we as humanity working on a lot of topics with regard to sustainable development. And I wanted to bring you a little bit of, I would say, heavy infrastructural topic today and tell you what inspires me, what I'm working on, share it with you. So I will be happy to answer any of your questions while we are going through the material today. So feel free to do it in a very interactive manner. And I also brought a little bit of interactive content. So we'll be asking some questions. This is personally something that I found really interesting. So I would love to give you a couple of data today. So we'll be also using the chat. And so a couple of words to myself. My name is Alexandra, and I'm the co-founder and CEO of the company named Staex. I have 15 years experience working for IT industry. I've been working for bigger integrator companies or service integrator companies and spent a lot of years in research and working for Deutsche Telekom. And within Deutsche Telekom, I had a chance to really go deeper into the whole interesting topic of distributed technologies. And we are based in Berlin, and Berlin just happened to be somehow ground zero for all this distributed tech space. So also if you are willing to somehow get some connections to this or any type of access to this infrastructure, also feel free to connect with me. I will be happy to guide you into this world or make any introductions that you find useful for yourself. And so within the laboratory, I've been doing a lot of research with regard to distributed systems. That's where also the whole Staex idea has been born. And and what I would like to bring to you today is how we can actually build sustainable IT infrastructures based on distributed systems. And I would like you to just have a different view on the distributed stack as opposed to, I would say, kind of rather general knowledge on, there is Bitcoin and it's very, I would say, energy insufficient. And that's why we should actually not work with it. So I would like you to have the key takeaway from the session that this is not only Bitcoin, and there is a lot of other interesting things in this space. And actually we can build very interesting zero waste IT approaches and be more sustainable with regard to our infrastructures in the future. So this is a short intro, and let's start the session. So we're going to be talking in the beginning why I actually connect to topics, why it might be interesting to look not only into sustainable I would say production and supply chains, but also look actually into the guts of our IT infrastructure and why these two words are actually in one sentence. We also will look into today's problem and how unsustainable IT integrations and data usage is actually, or how unsustainable it is today. And then we will go to why this might be interesting to look actually into the infrastructure and what is the infrastructure, and how this can also help us to be more sustainable in the future. Then we're going to be also looking into how the infrastructure actually impacts our economy. I think it goes already without saying that in the last decades, we have proved from the IT perspective that the actual IT infrastructure impacts heavily what is happening on the economy, part because the presence of internet or shared platforms, for instance, impacted our economy really heavily. So it actually makes sense to look into how infrastructure is evolving, because the infrastructure is the heart of how or in which direction the economy can actually be developed in the future. Then staying still on the business level, we're going to be looking at the problems that we see, which actually lead us to more unsustainable businesses today, and how actually on the business level we can solve it. And then we'll also be then going down back to the infrastructure and seeing how we solve it today, which ideas we bring to the table. Surely it's not only the one solution, but just like giving you a glimpse into how we think and approach the whole thing. All right, so I will be jumping in our session here and there so that I see whether you have the questions or not. So if I'm lagging behind one of the question, don't be angry with me. All right, so why sustainability in IT? I think at least our Staex perception, or my perception, I would love to stay in the digital world as we have it today, and we have amazing platforms, and we would love to have even more digitalization for the future. So it's not I don't want to have this trade-off, like, this is maybe not that sustainable, so we have to stop doing everything. So I'm more a fan of like finding the solutions that can help us to be more digitalized, create more digital products. However, also look into the how we can actually do it in a more efficient manner. And so the problem is, and why we're actually talking about this, is that the IT industry already has a very impressive CO2 footprint. And the basic truth is we're going to be building more shared economies, we're going to be building more digitalization, we already have digital money, and a lot of the financial sector is actually heavily going through the whole development with crypto, etc., into the digital world. And so I personally think that we can now look into the IT infrastructure, and actually we have the possibility to rewire our IT landscape, because we have the information about the global warming, we have the information about CO2 emissions, and we now, becoming even more and more digital. I think it's really time to look into this and to create really future-proof infrastructure, for a real future-proof infrastructure for the future of IT. So let us look into the challenges that I brought to you. So we're going to have 3 quizzing questions about the IT usage, and I just wanted to show you, at least that was an interesting data that I found through my research. I didn't know it before, so I think it's always interesting to look into this. So the first question is like, I will just read it out loud. It's on the left side. What percentage of the average service compute is in actual use today? So the answer will be something between 0 and 100%. So what do you think? We have all the servers and data centers. So how much of this capacity in percentage is actually being used by our services today? What do you think you would guess? You can just post it into the chat. 5 to 10%. Thank you, Nicholas. Yeah, so actually looking into the number, this is a very, very good guess, but it's a little bit more. So you've been even, I would say, more pessimistic with, but it's just actually only a quarter of what we have built so far. Actually, this is a scary number because looking into the amount of data centers that we're building, now, of course, all this kind of mining pools are coming to this, but this is actually really interesting to look into, that actually 75% is somewhere idling and not actually being put into use. So then coming to the 75%, we talk about idle resources. And then I have a question. So I want to have the, servers, they still consume the energy. So how much of this, again, the answer is in percents, how much of this energy that they would consume if they would work at full power, they consume when they are at idle. So again, the question is in the chat. So again, from 0 to 100%, take a guess. So when they are not under the productive load, Nicholas, you say it's 50%, 20%. So it's 17 to 25%. Leonard, you've been close to the numbers. So you can imagine that, again, having taken here 25%, the quarter of the actual power, and then all the servers working, and it still is super huge number because the servers have to be maintained, and they still consume a quarter of the amount of energy that they would normally use if they would be loaded. All right, so now the last thing, it's now coming to the end. The internet uses a lot of energy, and there was a research looking into the amount of energy that the internet actually consumes. And if the internet would represent a single country, what would be the global rank for the energy use of this country? Let us imagine there is the country named Internet, and it produces CO2. And what do you think is the ranking? This is now the number. It's from first to place number, I don't know, 100. What do you think would be the rank? Number 1. Well, let's come back to the slides. It's actually number 6, which is not the number 1, but still pretty impressive. And I think these are definitely the numbers that are interesting to digest and interesting to understand, because we know a lot of projects that are working towards optimization of CO2 emissions. However, actually, a really huge problem it is the internet. And let's take a look how we can make it more sustainable. So then the challenge number 2, it's actually very interesting because it's also the topic of our conversation today about the data usage. So we have the oil rig now in the picture. There are lots of them out there. And every oil rig has around 30,000 sensors that are actually equipped on this oil rig, which is also very interesting. So what do you think, how much, again, the percentage of the generated data, so basically all the sensors, they generate data, and so how much of the generated data is actually examined and analyzed beyond just being fed from systems? So what percentage of this data we actually put in use? Again, the question into the chat. What do you think about it? Exactly, Nicholas. This is compared to the total energy use of each other country. Anna is voting for 15%. and there've been 5% of data exploited. Nicholas, thank you for your answer. Anna, thank you for your answer. So it's only 1%. It's actually also really interesting when we found it. So this is now with the example of the oil rig. However, there are multiple systems out there that are already equipped with a lot of sensors. And so I think we are, as a humanity, with regard to how actually we use this data and what we do with this data, we are, under 5% with regard to all the systems. All right, so no quizzes anymore. Thank you for your interactive participation. Thank you for your answer. I hope you learned a couple of things from the session already. So now just a couple of numbers that I brought to you. Let's look into the how our IT, like not only the internet itself or data usage, but also the IT integrations are non-sustainable. So we invest around $380 billion yearly into the different IT integrations, meaning we don't have actually standardized processes, and all the systems are, or a lot of systems today, very cumbersome, and we need to do custom integrations. Myself coming from the enterprise experience, each new service that has to be built, there are custom solutions, and we have to integrate a lot, be it with legacy code base or maybe some new applications that are coming on the market. And so this is the number. And to put it into perspective, is actually 1/3 more than the actual expenses on apps. So imagine you're working in a company and you plan, I would say, just a imaginary number, 9 million for certain application to be developed, and you can already plan 12 million on top, because you would know that there are certain integrations that have to be done. So this is actually how IT integrations around new services are very, very heavy. And also looking into the time that companies spend to integrate and integrate infrastructures between itself, integrate machines between each other. We take a look at like average integration project time around 1 year. We've been very generous because I myself also experienced projects that would go for years and years. Some projects go up to 10 years. And so it's basically also a huge amount of time that we are losing, as opposed to having new services faster, and so that we as customers can start enjoying the new services and applications. So why actually it makes sense to focus on infrastructure? And I know the infrastructural topic is very heavy, and not a lot of startups are looking into the infrastructure itself. But this is very interesting because today, even the best practices for energy efficiency, or the guidelines from EU how to make software more efficient, they are not really implemented today. So it's a really hard topic, and there are no standardized tools how to actually how to make my software efficient. And then all the efforts that have been undertaken by the companies that actually produce server hardware with regard to how to make it more efficient from the mechanical and electrical perspective, they unfortunately produce only marginal improvements. So we've really reached some kind of stagnation with regard to improvements there. And that's why the truth is that it actually really might make sense to look into this layer, which is the infrastructure, so which is running on on these actual servers, and is actually located between the apps and between the hardware. So this is the infrastructure, and so it really might make sense to look into this this piece. So now, coming from the data that we've been exploring and why it's actually interesting to look into the infrastructure, let's take a look from the economical perspective. I think it's really interesting to always map these two layers. Looking into the Industrial Revolution, how it was happening and what was actually the shift. So if we look into the scheme in, we have more output only if we have more input, which used to be the traditional development before the revolution. Then through the Industrial Revolution, we came to this economies of scale where we would say something like steam engine, which would be in this case a general purpose stack. This will decrease the cost of the input, but have the higher output, right? So this is actually this major leap that has been done within the Industrial Revolution. And so comparing to the information economy that we have today, and we all know the Moore's law, then if we will double the number of transistors per chip every 2 years, or the number of transistors is doubling per chip every 2 years, we actually have this exponential growth in data processing, right? This is what's happening today. You all see this on the market. We have achieved really great results in the last years. And so if we will, or this really fast data processing, is this the general purpose stack for Industry 4.0 or for the next evolution in our economy? So the answer is actually no, because there have been also really interesting studies on the topic of, you see it on the right side, breaking up the data silos. So the truth is, if we will only continue to process data faster and faster, yes, it's true, it will help us to analyze more data and to process a huge or a large amount of information. However, this will not bring us the revolutionary results. It will only bring us the revolutionary results if we start connecting the data. So if we will connect the data from this oil rig with the CO2 data, and then we will be able to see or to make more complex predictions. And that's why in our perspective, in my perspective, it's really interesting talking about this next evolutionary step, not only into working in a certain, I would say, IoT space or a certain use case and look into the data there, but start linking this data cross use cases, cross silos, because only then the potential of what we can unlock or the value that we can unlock will be really interesting. So the hashtag breaking up data silos, this is the real interesting piece in being more sustainable as opposed to exploiting more and more the data silos one by one. Staying on the business level, let's take a look why this kind of more siloed approach or why this leads to certain problems. So just taking a look at the classical supply chain, and this is how it's structured today. It's very linear, and that's what I was describing before. So every kind of step at the supply chain, manufacturer, shipper, warehouse, has its own kind of data silo, and this is actually very not really dynamic, not really flexible. And if something happens at the customer side, it's very hard to track the problem. It's very hard to make transportation and warehouse to talk to each other. I think that's probably what we have today in our mind, like everything is connected, everything talks to everything. However, it's not like this. Every kind of step at the supply chain, for instance, has its own data. And of course, you know, the captain of the ship is, you know, might be talking to somebody at a warehouse when they arrive. However, on the data level, the integrations are not happening. So this is really complicated today. So what I would like to give you this as a solution, and this is how actually all this kind of decentralized topic is coming into place, is instead of having it more linear on the business level and going like step by step from one data silo to another one and trying to put them together into one certain use case, I think it makes sense to actually flip the switch and refocus the whole thing, where we have here the fingerprint, as you can see in the middle, and this is actually the actual customer, and make it in a way customer-centric, so that by the end of the day, the whole goal of the supply chain is to deliver value to the customer. However, in this case, you can see the solution from my perspective is to, instead of having this very linear supply chain, but to have it more circular, so that actually every participant can talk to every participant on a network, and they all contribute to the actual wealth of the user, or they provide a certain value to the user, who is actually in the center, because actually this whole service has been created for this particular user of this particular platform. And so here the solution also on the business level, and now again coming back to the infrastructure, this is the interconnected and shared infrastructure. So for instance, one simple example is something like, in such flexible and dynamic systems, we can start using the KYC processes, maybe across services. So I think each and every one of you have been already experiencing like each new app or each new service that I have to use. I have to be onboarded, every time. And so I've myself done already, like, I think 30 times KYC for different platforms. So each time I do it, I actually ask myself, why can it be in my wallet, and why they cannot just, request the data from my wallet, so that I've been onboarded already once, and they can just have a proof of that I've been onboarded onto this platform. So this is like one use case. Another, I think, important thing, it's that is kind of being leveraged through such a system. It's very flexible business models, because looking into the business models today, looking into the shared economy, the business models that we build today are very non-flexible, because if we build a certain shared economy, we have certain suppliers that can be connected, we have certain buyers that can be connected. However, this is only within this use case, and if we want to actually extend this use case to some other parts of the community, it's actually very complicated, because we have to create new interfaces, we have to rechange the platform, and this is a huge overhead today. Yeah, so this is the business, and looking into the incentivization. So why we actually talk about the crossing the silos and having these shared infrastructures. Also another interesting data about the potential economic impact by the IoT industry. Insane number, around $11 trillion per year by the year 2025. This is the number that's the economical impact of the IoT industry in general. However, this is really interesting. This will be only happening if we're going to be having the, you can see it on the right side, the collaboration between business models on the vertical level. Again, so the same, if we would have different silos talking to each other. So for instance, if we take e-health and all the different digital systems that we build there, a huge chunk of this data actually needs to talk to a lot of IoT data, right? So we have the pacemakers, we have the smartwatches, and so only in actually connecting these two areas, we're going to have this economic impact that actually have been predicted. And again, when we start to using this data more efficiently, right? Instead of this, we remember about the oil rig 1%. then we start linking this data between different use cases, and then we have the potential to actually at least go from 1% higher and higher through the amount of data that we use. So now coming to the or coming back to the topic of infrastructures after the, I would say, more economical impact of how the infrastructures can impact the business and vice versa, and talking about what do we actually want to achieve in the business in the next years. The next generation of information economy, as opposed to what we have today, which is, I would say, less flexible, less dynamic, more siloed approach. And so this next generation will only grow through leverage and shared IT infrastructures. And so the interoperability between infrastructures actually is the key to success and can lead us to zero-waste IT economy, because we will start looking into the data, we will start using the data much more efficiently, and we would not repeat, like in the example before, the KYC processes all over again. Then it might be in the future possible to just do it once, and then because services are, or infrastructures are interlinked and interconnected, they will be able to actually use this fact that you've been already onboarded all over again. Here, on the infrastructure level, I think it's also very important to look into the new coming infrastructures, because this is still, I would say, being a little bit ignored by the enterprise systems. All this world of blockchains that is arising. I know that currently today it's used for, or more or less for, crypto and financial use cases. However, this is an amazing infrastructure that also can leverage beautiful machine-to-machine economy, etc. So our, I would say, legacy or existing infrastructure also needs to think about how to actually interconnect with these new things that have appeared on the market. And this is also a question of how we can connect them together so that we can actually achieve this interoperability on the infrastructure level. All right, I've been checking the chat. So from now, getting back to the, I was saying this is more technical session because we are on the infrastructure. So we see the solution that can be created in 3 parts, and I'm sure that there are, I would say, a lot of bits and pieces that are needed to create such a shared infrastructure. And actually also talking about this, I would say, kind of, I was describing it from the perspective of the economy. So we will do this next generation step into the new economy. You might also, some of you have seen it as the kind of these buckets, Web 2.0 and Web 3.0, where we say that Web 2.0, it was the front-end revolution, where we as users were able to interact with our platforms, and this is like gave all this rise to shared economy, and we were able to have the programming languages for our front ends that would enable the interactive exchange, so to say. So speaking about, or like kind of my bucket where we are today, this is the Web 3.0 that is currently being built, and again, coming to a lot of pieces that we still have to put together. And it's also been called like the revolution of backends, so that we have the ability to actually interconnect the backends. So first part is the network. I think it's very important to look into our networks. We have a lot of protocols on different levels, so it would be so amazing if they all can, not all, but some of them can talk to each other one day. So first of all, the interoperability of our things, because things are the major driver of the economy, because all the communication is happening through our devices. And then also talking about the simplicity. So actually these networks, these flexible dynamic networks that will be created, it will be amazing to have very simple procedures how to join them. And also here important that I was describing before, like how to actually be interconnected with all this blockchain infrastructure world that is not only good for crypto, but that actually we can post some of the machine transactions onto the blockchain networks. Like for instance, if a car is paying on the gasoline station, then it would be amazing to have this transaction somewhere stored that this transaction actually happened on the blockchain. Then also getting to the management layer, this is also very important. So also our management, or the technicians would call it control planes, need to change. So it shouldn't be these monolithic blocks that are responsible for one platform, and then another monolithic block is responsible for the other platform, and it's super hard to make them talk to each other. But actually that the management and orchestrations should be happening on a more kind of granular level. And also collaboration, because we can only build flexible and dynamic structures if we would actually support this consortia building, where companies can start trading between each other, where they can start trading also data between each other, can happen much more simple. I still talk about the IT, so that we can enable the companies to discover each other much more easily on the network, and so that new partners actually can be integrated in a more simple manner. So this is what we are doing at Staex. This is the approach that we've chosen. So we have a decentralized platform. In our platform, you don't have any central component. And if you want to have it central, you can have one component instead of making it 10, so to say. But I always say, like, it's super easy to make a centralized system out of a decentralized, but it's very hard vice versa. And so this is what we are providing. We provide secure networking. This is the heart where we enable the machines and partners to be interconnected between each other. And they form the so-called swarm cloud. This is the metaphysical entity or distributed cloud. And then go into the management layer. This is where we have a blockchain-powered platform where they can actually manage the applications and services and the connections to them through sophisticated manners as consensus. And also very important to be dynamic and flexible, addressing the hybrid IT needs. So actually our agents can be installed on little small machines or on-premise services or in the clouds where the use case is needed. And so just so that you see and now map to this business idea that we had before, this is how the new, I would say, supply chain would look like. Instead of having this one by one going from silo to silo approach, you have a more kind of star-shaped approach, or the peer-to-peer network behind, where, for instance, you build a car and you have the automotive company in the center, and all the vendors can easily plug and play to this kind of particular value delivery system through these connectors that we provide, as opposed to how this would be working in the I'd say old world, where you have to integrate each and every vendor separately, and actually it's a very, very cumbersome process. Finalizing, I took a little bit more time, sorry, but I was told that I can make the session a little bit longer. I think also this is our solution, but also kind of broadcasting to the world. I think that three important things need to be achieved. We need to have interoperable networks, we need to have interconnected management, and the possibility for ubiquitous collaboration, because only then we can actually break up the data silos, leverage finally the data that we are gathering even today, and have more efficient infrastructure as opposed to kind of more centralized processes that we have today. Again, the example with KYC. And only this will actually help us to get to the era of the zero-waste IT infrastructures, hopefully. All right, so thank you. That was my session. I hope you have enjoyed the information. If you are interested in the topic, please reach out to me on LinkedIn or by any means, and we can have a conversation. Now maybe looking into the chat, if you have any last questions for the session before I close. Thank you, Anna. All right, so very cool that you've listened to me. Then I will be concluding the session, and great that you stayed with me for the whole hour. So enjoy the rest of the day, the rest of the great Startup Night event. Hope that you have a lot of insights, and see you. Bye-bye.